Hello everybody, it is Mr. Trochet with another video lesson. We have 8.1.1, new chapter, new lesson. Let's get going. This lesson is really difficult as we are in distance learning. It's really difficult to figure out how to do this because we're supposed to be measuring a lot of things in the classroom, desks, the classroom itself, posters, all these things. And usually you get a ruler and a measuring tape, and you kind of compare with your peers and your partners if who's accurate or who's the most accurate, et cetera, et cetera. So we're going to actually skip this part. Basically, it says which tool is more precise, what is the actual length of the classroom, and this is all just in class. The one thing is that our information for this lesson, let me change my mouse so it doesn't, I love these fireworks though, I'm not gonna lie, is that I'm gonna use this data here, and I'm gonna put this on the altitude card where you're gonna use this to do your lesson and everything. But we're actually gonna kind of walk through it a little bit too. So here we have, for 4 it says, sorry, let's take a look. So it says add your data to the class data table. So we're going to have the data here already, and we're going to take a look at this. So here are all the measurements with students with a ruler, and here are the measurements with a tape measure, the ones that like stretch out and come back in. So what it says here is examine the sets of data. Record any initial observations you can make. So for this problem for A, you want to just look at the observations here. So measurement rulers, and if I'm going to make an observation right at the top of my head, I'm looking at this, and it seems that we have a lot of measurements in the, looks like 330s are pretty popular here. I don't see any huge numbers or any big differences, but again, I would say 312, I'm going to go ahead and write this down. 312 is a pretty low number, and then we have 346 is a pretty high number. And I like to look at the mins and the maxes, the highs and the lows, just to kind of get a gauge of how far apart or how inaccurate some of these measurements were. Now let's take a look here. Our lowest one looks like 330. Yeah, it looks like what is this one? 241. That is interesting. Why would someone measure 241? I think that might be an error in measuring because if everything else is 300s, they probably just miswrote the number from 241, which should be 341. But I don't see, besides this one right here, I don't see any big numbers outside of 340. There's 341 here. So what I've noticed here is that the 341, and this one says 241, which I don't think is true, and then here we have 312 here, and then 346. 346. So my observation is that measuring with a tape measure is going to be more accurate because we have a wide gap here. And this one, again, I still think this is an error by misprint. It should be 341. But if that's the case, then obviously one person messed up doesn't mean anything. I would say that the next lowest one would be 330 here. So that means it's a difference of about 11, and this one's a difference of about 30. So this one has a difference of like 11 inches for discrepancy. All right, so that's my observation. Are there any measurements that look very different from the others? As I mentioned before, you can use that example. Yes, there are some that look different. These extreme values are called outliers. Like I said, the outlier here is 241. That's an outlier. So that's an extreme. What could you do to help you to see any outliers better? One way that you can do it is go from least to greatest. I would recommend that. So least, organize it, least to greatest. Yeah, that's what I would do. May take you some time, but that's one strategy. Sometimes outliers can reveal that an error, oh, look at that, I just said that, or a misunderstanding has occurred. Yeah, so I mean, outliers happen all the time when we record. We all make mistakes. So I think that's an error. Decide as a class if any data needs to be deleted or corrected due to an error. Again, I believe this one needs to be corrected. So we're on pace to do a really good job here. that would be the error. So I would go ahead and write that down. All right, what is the range for each set of data? How do the ranges compare? Again, the range is from min to max. And again, I, of course, wrote those down. I wanted to make sure I organized my data so I knew the range and how big of a discrepancy there are between a ruler here and a measuring tape. So, so we have 312, and then that's to 346. I think that's the most. I could be wrong, but I'm going to go through. Oh, here it is, 239. That is, so these, I think these are the same students. Now that I'm looking at that, those are probably the same students that measured with a ruler and a tape measure, and those are just an error. So let's pretend, let's just cancel those out. We're going to not even look at them because they don't mean anything. So 310 to 346, and then we have 330 to 341 for the bottom right here. So we have the top 312 to 346 and the bottom 330 to 341. This one is a range of 11, and this one is a range of, looks like 34. And that's a bigger number, which means that it's a bigger discrepancy, a bigger variance. So it's not as accurate. All right, let's go ahead and go here to 8-5. Let me save the mouse and, oh, actually I can erase here. So let's go ahead and go create visual representations, make a histogram. Now, you may have not been very familiar with histograms, and I understand that because it's been a tough year. However, histograms, let me go ahead and go over something real quick. I used to teach histograms in high school, and I had this little PowerPoint here. So what is a histogram? So basically, it's a histogram is like a bar graph, but where there's no gaps in between. So as you see, they're together right here. They touch here, they touch here. So that's the first thing. The next thing is that there's ranges, and the ranges are included. So from here to here, everything in between is from 0 to 5. So if I had, for example, 4, 5, 6, 5, my 4s obviously would go here. My 6s would go here, but where would my 5s go? Well, my 5s have to go as well into this little green thing right here. And we need to make sure that it is 0 to 5, and then there's a break. 6 to 10, break. 11 to 15. There's no repeats, right? You got to make sure, because some students will go 1 to 5, and then they'll put 5 to 10, and then 10 to 15. We don't want that. These are repeats. If we're breaking it, this needs to be a 6. And then this one needs to be an 11. All right, so we got to make sure they're separate. So that's the main thing about histograms. Now, the last thing about histograms is that this is the number of people per bar, okay? So if I asked you how many people voted M&Ms as their favorite candy in their groups of years, some people are like, well, there's a total of 50 people. That's incorrect. So this one right here, for example, let me go ahead and clear the screen. This one right here, let's say this is about 2 people. So 2 people here. This one would be about, let's just say that's 26. 26. And then this one would be, let's say it's 45 here. This one is 50. This one is, let's just say that's 40. And this one, let's say that's 25. So you need to make sure that how many people had M&Ms as their favorite candy. It's not 50, it's 2 plus 26 plus 45 plus 50 plus 40 plus 25. That's how many people voted, okay? And they just break it up into the age groups, okay? All right, hopefully that labels that out for you pretty clearly. So you need to make a histogram, and you're probably like, oh my gosh, I don't know where to start. Don't worry, I'll help you set up a little bit. Use the same scale for both histograms, okay? So we're gonna use the same scale. One thing that you wanna do is first you're gonna start like a little L right here, right? And then we're gonna use the numbers here. So let's say I have a minimum of 312. What would my starting value be? That's an interesting question. What should my starting value be? Well, Here it says 0 to 5. Do I want to start at 0 to 5? No. I don't want to start at 26 to 30. No. What I want to do is I want to have a little break here, and I'm just going to do a line right here. This is just going to be a break in the graph. This is nothing. But from here to here, I'm going to say that's 310 to 319. And that's going to be this bar graph right here, right? That's going to be my bar graph. And then the next one would be 320 to 329. All right, so I'm ending in my nines. And then that's going to be this bar graph right here. So let's use the numbers. So 312s, so we want anything from 310 to 319. So there's 1, let's see, 310, 319. There's 2, and 310, 319, 3. So there's 3. So then you go back to your graph and you go, so I'm going to say that this is like, I'm going to say, what should the value be? 2s, maybe? I'm going to start with 2s. 2s, 4s, 6, 8. And obviously your graph is going to be way bigger than this. I'm just giving you an example of how to do this, okay? So, and then this one's going to be, if I were to clear this up again, I'm going to use blue here. So then that's 310 to 319. And then my graph is right here. So that's going to be, here's 2, then that's 3, then this one would be 4. So this is a 3, and I'm going to write it inside. Let's go to the next one. I'm going to go from 320 to 329. So 320, there's 1, 2, 320 to 329. Any 20s? 3, 4. So there's 4. So 320 to 329. Let me use a different color. Let's use this pink one. 320 to 329. So that's 4. And there's no break, right? It's right there, 4. And so you're going to do this for each number, okay? I don't want to spend too much time on this because I don't want to take up the whole time, but this is an example, all right? At the very end, you can take a look at one of the answers I'll show you at the end, but I just want to make sure that's clear. Go ahead and try this on your own to your very best ability. All right, it says create a box plot for the 2 sets of data. All right, let me pause real quick so I can bring that screen up here. All right, so we're going to resume coding. So a box plot, let's go ahead and clear this off. Clear, oops, back, clear this. There we go, pen, clear, okay. So box plot. So this is a box plot. So you have your minimum, which is your interquartile. Interquartile, first quartile is here. This is your median. I'm sure you know how to find the median. Your third quartile, and then your maximum stuff. And so we're going to be talking about that. So the first thing is do what's easiest. Median, what is the middle value of the data set? So you have to make sure you put this in order. So you need to organize these numbers, and I would suggest putting them in order for this box plot, okay? So that's going to be the very, very middle right here. That's where you're going to start. That's probably the easiest way to start. The second thing is the middle number between the smallest number and the median data set, but not the minimum, all right? So the middle number between the smallest number and the median of the data set. So smallest number here, and the median, and that's going to be your quartile 1, okay? And then third quartile is the middle value between the median and the highest, but not the maximum. So these maximums and these minimums, these are the outliers. So we don't focus on those. So we kind of just like keep them away. And we just focus on the ones that we do have. So for example, let's take a look at the small numbers. So we're going to take away, I'm going to remove that and use this pen. We're going to take away this minimum, and the maximum we have is 340, yeah. So then we're going to take out these 341. So let me try again. So 341, 241, those are gone, 239, and 345, 346, there it is, 346. All right, so those are gone. So we want to know what the middle number is, and you got to find the middle number, and then you're going to take it with the highest number, which would be 345. So 345 is here, and you would organize it out. Unfortunately, I don't have the time to do this, but I'll happily show you a box plot with the answers. But go ahead and pause the video and work on this to the best of your ability. I will try to see if I can put a question or a link to these box plot things. And this is kind of like the stats where we're going, but that's a lot of stigmas. We don't need to worry about that. All right, give me a pause real quick. All right, and we are gonna get moving on to the next one. Oops, let me do that. There we go. So we make a histogram, we make a box plot, compare the center, shape, and spread outliers for the two sets of data. So we're gonna compare your histogram and we're gonna compare your box plot. And what do you notice? What do you see? What do you look at? And then it says, what is the measurement best? But we're not going to do 8-6. I think that's going to be enough work for you for today, because it's actually very time consuming, this stuff is. So just a little 8-4, a little 8-5, and we'll call it a day. I'm going to put this on here. Khan Academy has a nice little review of everything and gives you an example of how to do things step by step. And I think that's going to be way better than me doing this video. And then there's some examples of how to do it. And there's some videos as well. So check out this video right here. So I'll copy this link here. Thank you for your patience and all that. We're going to go ahead and show you the answers in terms of the plots, the box plots and all that. Let's go ahead. So let's take a look at this. So like 310. Oh, so they went from 310 to 315 and then did 316 to 320 and then 321 to 25 and then 30 and stuff like that. So that is one way that you can do it. If you're using the sample data, here's the one. So we have 312 is down here. 346 is up there, just like I originally said. We're not using those outliers. So 312 and 346 are the max and mins. You should have 324, 334, and 340 as your quartiles for the measuring for rulers. Now, if you look here, we have tape measures at the bottom. So the tape measure is going to be 330 is the minimum, 341 is the maximum, 336, 337, and 339 is the quartiles. Okay, so that's what your box plots should look like, and then that's pretty much it. And yeah, that's it. So you have your histograms here, and you got your box plots, and I think that's a solid day. Yeah, and obviously these answers vary. I already went over those, but that's going to be it. So have a great, wonderful day. We will be talking more about stats and stuff in class. I'm looking forward to it. And yes, good luck on your homework today. Have a great day. Bye.